Hello scholars, let's go over our first review of derivatives. So there's a front page with some major key concepts and parts of derivatives that I've written out for you. Alright, I'm going to start with the first set of exercises from the AP exam on derivatives. So number 3 here is non-calculator active. They give you f of x, and you need to find f prime of x, which is the derivative. So I'm seeing that I'm multiplying two things here. So I'm going to apply the product rule. So I'm going to write that down, product rule. So I'm going to split up my two parts that are being multiplied, x minus 1 and x squared plus 2 to the third. Then I get f prime, which is 1, and g prime, which is, I need to use the chain rule, so I'm going to bring the exponent down first and subtract 1, so that'll be 3, parentheses, x squared plus 2 to the second power, times the derivative of x squared plus 2. So that's going to be times 2x. If I multiply and combine like terms, I'm going to get 6x times x squared plus 2 squared. Okay, time to put my information together into our formula, f prime g plus f g prime, following what I have here. F prime, if I look for it, it's 1. G is x squared plus 2 to the third. F is x minus 1. And g prime is 6x times x squared plus 2 squared. Now if I look at my multiple choice options, I don't see it right away. So I need to do a little bit of manipulation, make sure that I have it right. So I see from these two terms, if I split it up at the plus, that they both have x squared plus 2 squared. So I'm going to factor out x squared plus 2 squared and see what's left. I'm going to put it in huge brackets. Okay, if I take out 2 here, I'm going to be left with only 1, so I'm going to have x squared plus 2 left. Plus, since I've taken out x squared plus 2 squared, I'm only left with 6x times x minus 1. Now I'm going to pause and take a look at my multiple choice options. It's not there yet. Okay, so I need to do a little bit more simplification. I distribute the 6x, x squared plus 2 squared times x squared plus 2 plus 6x squared minus x. Last step, let me try to combine like terms. Okay, I see an x squared here and a 6x squared here. If I add them up, I'm going to get 7x squared. All right. Ooh, I made a little mistake here. 6x times 1 will be minus 6x. Okay, forgot the 6. All right, let's get back on track. Combine the like terms. 7x squared for these two. No other like terms, so I'm going to put minus 6x plus 2. I'm going to pause, and I see that in my multiple choice option D. Okay, next one, number 8. All right, if f of x is cosine of 3x, then what's f prime of pi over 9? Well, in this situation, we need to get the derivative first. Then we need to plug in pi over 9. Okay, so we need to get the derivative of cosine of 3x first. Let's work on that. F prime of x. So the derivative, so we need cosine of 3x. That's the original function. We're going to have to use the chain rule here because we see a cosine of x, but also there's a 3x inside the parentheses, so that means we have to do the chain rule. Okay. The derivative of cosine is negative sine of 3x. But then we have to multiply this whole thing by the derivative of 3x, which is 3. So if I simplify this, I get negative 3 sine of 3x. This is my derivative. Now to plug in f prime of pi over 9, I need to literally substitute that in for x. Okay, I'm going to cancel this. So I have in my situation here negative 3 sine of pi over 3. Okay, so at this point, if you don't have a calculator and you're not used to getting the sine or cosine of pi over 3, or you might have forgotten, we need to do the process of elimination, okay? Sine of pi over 3, if I draw my coordinate plane and I try to remember pi over 3, well, I know this is 0, I know this is pi, so pi over 3 is going to be somewhere here. Okay, and I know that sine is between x and y. Sine is the y value. So I need the y value of pi over 3, which is here. So I got to think, okay, is this y value positive? Yes, because it's up here. Whatever this value is, whether that's square root of 3 over 2, 1/2, or 1, since I don't know, I know it's positive. So I know my answer is going to have negative 3 times something that's positive. Well, negative 3 times something that's positive, that's gonna have to be a negative answer. So I'm gonna cross off my positive options here. Great. So now I have to think again. Okay, well, pi over 3, okay. Pi over 3, if I change that into degrees, becomes 180 over 3, which is 60 degrees. Okay, so that's going to be 60 degrees, if you like degrees better. Okay, so that means that the y is taller than the x. So that means the y here, if you're choosing between 1/2 or radical 3 over 2, it's going to have to be radical 3 over 2 because square root of 3 over 2 is greater than 1/2. So I'm going to have negative 3 times square root of 3 over 2. And if you remember, within the first quadrant, the options that we have are 1/2 or square root of 3 over 2 or square root of 2 over 2 as the values, okay? So now I've made a decision, square root of 3 over 2. This is my answer, and that's letter E. And I know that it's not square root of 2 over 2 because square root of 2 over 2 works for 45 degrees, or pi over 4. Great, let's move on to the next question. Okay, so for number 12, I still need to do a chain rule, e to the 2 over x. Well, first thing, our favorite thing, the derivative of e to anything is still e to the 2 over x. Okay, so that's wonderful and awesome, so easy for us. Now we have to do the chain rule and multiply this by the derivative of 2 over x. So I'm going to write that down up here, 2 over x. I don't like this format, so I'm going to bring the denominator to the top. I'm going to have 2 times x to the negative 1. And now I can apply my rules. Distribute negative 1 and subtract 1. So I'm going to get negative 2x to the negative 2. Okay, so I know my answer has to have a negative 2 in it. I can cross C off, B off, and A. I'm left with either D or E. And I know that this is equivalent to negative 2 over x to the second, e to 2 over x. And I'm golden. For number 13, it's still asking for the derivative. However, they do want you to plug in natural log of x into the function first. So f of x is x squared plus 2x, and I'm going to plug in natural log of x. So I'm going to have f of natural log of x is natural log of x to the second power plus 2 times natural log of x. So now I need to get the derivative of this function. Okay? I'm going to do a chain rule. I'm going to split it up first, though, so make it easier on me. So I'm going to say, okay, that's going to be 2 times natural log of x to the exponent 1 times the derivative of natural log of x, which is 1 over x. Okay, for the second part, 2 natural log of x, so that's just 2 times 1 over x. And if I put them together, I have 2 natural log of x over x plus 2 over x. I try my best to find the match here. Okay, it's not this one. It's not this one. It's not this one. I'm missing a denominator. It's not this one for the same reason, so it's A. So this is equivalent to 2 natural log of x plus 2 all over the same denominator. Okay, so given a graph of function f, which of the following could be the graph of the derivative? So we have to write a few pieces here to help us out, okay? At this point and at this point, these are important to me because I know that the derivative here is 0. So I know the derivative is 0. The derivative here is 0 because the slope is a horizontal flat line. The slope of that tangent line is 0. Okay, and then this part I'm increasing, so the derivative is positive. I am decreasing, so this has to be negative. And I'm increasing again, so this has to be positive. So if I sketch that, if I sketch my derivative, I know it's going to hit 0 here and here, just like we said, 0, 0. Positive means I have to be coming from above, I'm above the y-axis. Negative, I have to be below somewhere. And then positive, I have to be above again. So a good sketch maybe would look something like this. Okay, so that means positive up here, negative below the y-axis, and positive above the y-axis again. So I'm going to look through my options and go through process of elimination. E doesn't look anything like what I made. D looks like the opposite of what I made. C, nope. So it's between A and B. Let me just make sure that my zeros are where they need to be. Okay, so yes, my zeros are right. Not through the origin, so it's not this one. It has to be B. Okay, so I'm going to go over the next set of problems in the next video, so please tune in. Make sure you rewind, go to a problem that you might want to spend more time on, and make sure that we are in agreement in it and we know what's going on. Thank you.